linked list implementation using Java. Linked list traversal, we will see. Linked list has operation, insert a new at the beginning, end, and a given position, delete the first node and delete last node. Okay, we'll see one by one. Representation. Linked list is a linear data structure. The element are stored in the form of node. Each node contains two sub-elements. A data part that stores the value of the element, and the next part stores the link to the next node. The first node is known as the header, as always used as a reference to travel the list. The last node points to the null values. Okay. For example, you will see the visibilities. This is a head node, next, null. We are adding here. The implementations, how we are implementing. So we have to create a two classes, one class for the node and another class for the linked list. For the linked list node for this each node, and this entire chain is called the linked list. So I'll class node into data and next. Okay. Linked list node head linked list, and then for the head initially I put the null values. It means some reference value will be there, only address will be there. Okay, now I'll copy this. This is my start of the program. I'll paste it here. Okay, fine. Now, next we are going to print the list. First, we will create the list. So, create a single linked list and print the list. Okay, now see this. I create a public static linked list implementation IM here implementations. So, I are going to implement. Now, create a linked list, my list. This is a list equal to new linked list. It means the node head will be created with the null values. Okay. Now node equal node first object I am creating new node. Then first dot data equal to 10 and the first dot next equal to null. And the my list dot head equal to first. The first will be the first node of the linked list. Now second. So this second node creating and a new node. Second node data equal to 20. Second dot next equal to null. Then first dot next already null values. So if a first dot next equal to second, it means the second node address will point into the first node. We are linking. Now second dot next is null. First dot next is not null. It will point to the second reference, second node reference. Now I created the third node. Node third new node. It's called new node. Okay. New node. Third dot data equal to 30 and the third dot next equal to null. Third dot next equal to null. This way created. Now third dot, then second dot next equal to third. Now third dot not null. So first node, the second node is pointed to the first node, third node is pointed to the second node. So it will print like 10, 20, 30. It will print like 10, 1, 30. Okay. Now I will copy this. This is my test of the code. I will add it here. Okay. One node is created for node. One is node is created for node. Another is for linked list. And the third, this is my third class. Just put here implementation. Linked list implementation. Just to save this program and run this. So no record printed because I am not giving the printing values. So how to print? That is called a traverse. It is called a traverse, linked list traversal. Traversing through linked list is very easy. It requires creating a temp node. You have to create one temp node, point into the head of the node. List if the temp node is not null, display its content and move to the next node using the temp next. Repeat the process till the temp node becomes null. Temp node becomes null. If the temp node is empty at the start, the list contains no items. Then list contains no items. This algorithm. Then we have created the print list. Is the list for the functions. Now see this void print list. Create a temp node pointing to the head. Then node temp equal to new space node. Then temp equal to this node head. So temp and head both are pointing to the same node. If the temp node is not null, continue display the content and move to the next node till the temp node becomes null. Okay, now print list. Now this temp is not null, then system contains the values. So I have checked the if condition and the else condition. If the temp is null means head has no values. It means head and temp both are pointing to the same node. So empty list. Okay. Now list contains while temp not equal to null, print the temp dot data. Okay. Then it is printing first temp dot data. First node is pointing to 10, then 20, 30. It has to print like this. Okay. Now I add this. I add this into my, what is called into my, I add this into my linked list method. It's a one of the method called linked list method called print list. Now, what is my list? My list. So I can put my list dot print list. That's it. So one simple program. So one simple method I call it. Now I'll compile. Now some error is there. My list, print list. Okay, what is the name? We are given print list. Okay, capital P. So save this. Java C. Java. So now it is printing 10, 20, 30. It's printing 10, 20, 30. Understood now? So first node is 10, so second node is 30, third node is 30. The 30 will have the null values. So if I want to add 100 nodes, I cannot give like this. It is a tedious process. So we need to go with some insert process. We need to go with some insert process. What is the insert process? What is the insert process? We'll see this. So insert a new node at the beginning. One process is the here I can insert, or here I can insert, or in between I can insert anything. Suppose we consider new node insert at the beginning. Here I am going to insert. So I'll create a new node. Okay, this address has to point to this, and the head has to point to this new node. That is we explained in the algorithm in the previous videos. Okay, if given list is 10, 20, 30, and a new element 100 is added at the start, the linked list becomes 100, 10, 20, 30. Inserting a new node at the beginning of the linked list is very easy. First, a new node with a given list is created. Okay, it is then added before head. So what is the algorithm we'll see? Push brand. It is called algorithm push brand. So now node, new node. So new node is created. This new node is created. New equal to new assigned to new node. Then new node dot data equal to element. Whatever the element I pass, it is assigned here. Now new node dot next equal to assigned to head. This head node I need assigned. Okay. Now head equal to new node. That's it. So make the new node as a head. Here make next node of new node as a head. Right? Next node as a new node of head. Okay. So now this is a push brand. This is one more method I added in my linked list. My linked list. The second method I added. Now if I go down, so this is my 3 elements added. So instead of adding, so removing, minimizing our programs. Okay. Now added, put this, that's it. My list dot push brand, push brand, push brand, 30, 20. Save this program, execute. So first value is 10, 20, 30. Now we'll try to add push brand 100. 100. As we discussed, I'll put a print list again. After adding, I'm putting a print list again. Save this. See this 10, 20, 30, 100 is added. So this is where you have to check. Okay. Next, if you go to insert at the end of the linked list, instead of I have created one linked list, I want to add in the last. That is called a pushback algorithm. It's called a pushback algorithm. Then say we allocate a node. New node equal to new node. Assign the data element. New node dot data equal to new node dot next equal to null. Here we are mentioning null. If it is a beginning push front, it means we are putting a head here. Okay, assigning null to the next of the new node. Check the linked list is empty or not. If the head is null, then head equal to new node. That is the start of the new node. Else, create a temp new node. Then temp assign head is assigned to the temp node. Now temp dot next not equal to null. We have to go through the temp node. This is temp is here. It has to come up to this level. This pointer has to move to third one. Okay. Then temp dot next equal to new node. That's it. Temp dot new node equal to new node. First, I'll copy this pushback. I'll paste it. Pushback algorithm after the print list. Save this. So what is the condition? Testing conditions. We'll check testing conditions. So here I'm adding pushback at 2030. Okay. So here it's printing front means front, the second front, third front. If it is this one, it will be reverse back. Okay. Now I'll comment this. I'll comment this. Save this pushback. Execute. Well, that's it. Then first pushback. So first added a 10. Then backside adding 20. Then backside adding 30. So it is adding. So now suppose I am adding 100. What will happen? Suppose I am adding 100. Pushback. So it will be a print list. Same process. Now execute. That's it. So it is added to the pushback backside. Is adding to the backside. Now we'll check for front. Wait, 100. So here last node means 100 is the last. Okay, pushback. Okay. So now if we execute. Now see this 300 not saved up. Push right now saved. Save. Yeah. So this is the content my list of print list. So I'm not putting a print list here. Save this. See this added to the front. Now it is added all the backs. Now added to the front. This way I am checking now. Now inserting a new at a given positions. Then in this method, a new element inserted the specified position in the linked list. For example, if the given list of 10, 20, 30 and a new element 100 is added at the position 2. This is 1, 2. Second position I need to insert. Okay, then we are insert 1, 2. Second position means the first position, second position. Before that I need to insert. So a new node, first a new node with the given element is created. If the insert position is 1, the new node is made as very head. Otherwise, traverse to the node that is previous to the insert position. This is previous. So insert position previous to the insert position and check it is if it is null or not. In this case, null, the specified position does not exist. In other case, assign next of the new node as the next of the previous node and the next of the previous node as a new node. See the figure, push at is called a procedure called push at here. So this address pointed here. Now this address you have to point to here. Then this address has to point to there. This one is to the A head node. Okay. Push at new element and the position, two parameter. So now node, new node equal to new node. New node dot next equal to new element. New node dot next equal to null. This node is created now. Now if position less than 1, no position is there. Okay. System dot outer position should be greater than or equal to 1. Then else position equal to 1. Then make next of the new node as the head and the new node as the head. That's his first node. Okay. So new node dot next equal to head. Head equal to get the new node is assigned to the head. Whatever the insert at the first positions. Else make a temp node and traverse to the node previous to the positions. Now this is the node created temp. Then temp head is assigned to the temp and the position -1. You have to go up to the position -1. If temp not equal to null, temp assigned to temp dot next. That's it. Okay, if the previous node is null, make a new node as the temp next, as a temp next and a temp next as the new node. Now temp node temp is not equal to null, new node dot next equal to temp dot next. Temp dot next equal to new node. Else procedure node. Previous node. See, now I'll save this position at okay. Now so that here I will add this. I will do the test conditions. In my program, I will push back, push back, push back. Then 10, then 20, then 30. Sorry, 10, 20, 30. Then 30, 20, 10 will print. Okay, now add 100 as a position 2. See this? We go there. I will test my see this. See this? 30. Here what is it? Push back. Push back. First 10 is prepared. And after that you have to push to 20. After that you have to do 30. Now 100, comma 2. 2 means one position, second position. So now 100 insert in between 10 and 20, 100 is inserted. That's it. Okay, now we'll go delete the first node of the linked list. In this method, the first node of the linked list is deleted. For example, the given list is 10, 20, 30, 40, and a first node is deleted, the list becomes 20, 30, 40. Deleting the first node of the linked list is very easy. If the head is not null, then create temp node, point into the head and move head to the next of the head. Then delete the temp node. Now this is called a pop front. We are removing the front node. If this dot head is not equal to null, then if head is not null, create a temp node point into the head. Temp is a assigned for this dot next, this dot head. First node I am hiding. Then this dot head is equal to this dot head dot next. So move head to next of the head. Then delete temp equal to null. That's it. Right. Okay. So this procedure I added for deleting. Okay. First I put it here in my list. So we need a test. First I am adding 10, 20, 30, 40. Then pop friend. Okay. Now what is the first element? 10. Then added 20. Then 30. Then 40. So 10 has to go. Save this. That's 10, 20, 30, 40. The front node will be 10. Front node, do throw it out. You throw it out, front node. Here is the last node of the linked list. This is same like a pop back. Temp dot head is not equal to null, only you can do. Fits. No record is there. Then no need for popping up. So otherwise, temp dot next, head dot next assigned to null. Okay, this dot head is equal to null. If head is not null, And next of the head is null. Release the head node. Release the head. So this dot head dot next. This is a pop back. Okay, now else same way you have to traverse. Once you traverse node, last node equal to this dot temp. This dot temp equal to null. And the last node equal to last node equal to null. That's it. Push back. What is my test code? It is no enter. That's 10, 20, 30, 40 added. The last node 40 is removed. 40 is removed. Then added first, then back 20, then back 30, then back 40. Now 40 is removed. So delete at the given position of the linked list. All will be the same process. Same kind of process we have to do. Okay. So hope you understand how to delete, insert, and what is called a list view. Okay. In subsequent, we will learn about other operations.